dear students, welcome back to my channel. My name is PrachiSharma and this channel is about learning chemistry for 10th grade ICSE. Now, on popular demand, today's session is based upon the observation questions for the study of compounds. So I have divided this into two separate sessions. The first session will be working on the first two chapters of the study of compounds. So that would be HCl and ammonia. We'll be looking at all the equations, what are the different type of precipitates they are forming or what kind of gases they are evolving. We'll do that for both the chapters. Then we'll work on the different characteristic of different gases that are part of the chapter. And then we'll work on a lot of questions. So make sure that you stick along in the lecture till the end, because I can assure you that all the observation questions would be extremely clear and you won't face any more problems if you stick till the end. So without wasting any time, let's get started with the session today. Alright students, let's get started with the first portion of the chapter, that is revising all the equations of the chapter HCl. So in this session, all of the equations would be covered in a single page. You can see that on the screen. So these notes are directly available in the description box, or if you can join the Telegram channel, you can go ahead and do that, because before the video is uploaded, you get all the notes sent out on the Telegram channel. Plus a few worksheets are also shared once in a while. So make sure that you join the Telegram channel and stay up to date with what is going on, what kind of notes are being shared. And the link for the Telegram channel is also in the description box. You can go ahead and click on the link. Now let's get started. I'll tell you what the concept is. So this first page is based upon HCl. Then the next page is based upon ammonia. And the next page is also half of it is ammonia, because ammonia of course has a lot of more equations compared to HCl. So let's get started with the first one. If you stick around and you look at these notes, these are all the important equations from the chapter. You don't have to go back and revise anything else from the book with respect to equations. And if you're confused about anything else, you can go ahead and check out the mind mapping equation, mind mapping video. So let's get started with HCl. So HCl, first thing that you have to remember is that it has a pungent choking odor. Why is it important to remember all of these kind of information? Because these are an essential part of your observation questions. You should know what a particular gas smells like, what the identification is, because only then you'll be able to identify what the question is talking about. So let's quickly work on these so that we can come on questions and see what the questions are and how we can answer them. Let's quickly start with this. So for HCl, the lab preparation that you can see is NaCl plus H2SO4. It gives you NaHSO4 plus HCl, and you have to maintain the temperature below 200 degrees Celsius. If the temperature goes above 200 degrees Celsius, so in that case, instead of NaHSO4, you get Na2SO4. Okay. Now let's move ahead to the next one. Now ammonia, when it reacts with HCl gas, it gives you NH4Cl. What is the observation in this case? It is dense white fumes. How can you get this question? They can ask you, name two gases that gives you a white solid, or two colorless gases that give you a white solid. They can also say, give an example of an acidic gas and a basic gas reacting together. So or in that case also, this is your answer. Now the next is metal plus HCl acid. So how does HCl acid react with a metal? It gives you hydrogen gas. So whatever metal is above hydrogen in the reactivity series, according to that, you'll get hydrogen gas out and you'll get a respective chloride out. Then when metal oxide reacts with HCl, so you have oxide and hydroxide. When that happens, you end up getting water. Because imagine, when the metal was alone, you are getting hydrogen. When the metal has oxygen with it, you'll get oxygen along with hydrogen. So that becomes water. Then when you have carbonate, that means CO2, CO3. When you have carbonate along with the metal, along with water, you get carbon dioxide. Okay. If you have sulfite, ITE, if you have sulfite, so in that case, along with water, you end up getting SO2, because you have SO3 connected. Then when you have sulfide, IDE, in that case you have only S there. So instead of getting anything along with water, you end up getting H2S. So make sure that you remember them in a particular pattern. When metal is alone, let's look at it again. When metal is alone, I get hydrogen. When my metal is along with oxygen, I get H2O. When I have a carbonate, that is CO3, in that case, along with water, I'm getting carbon dioxide. When I have sulfides, that means SO3. In that case, along with water, you get SO2. Then, when you have sulfide, IDE, there is no oxygen anymore. You just have a metal attached with sulfur. So, in that case, the hydrogen that was coming out will accept sulfur along with it, and you get H2S out. Now, let's look at this equation, which is right here. So AgCl in the presence of light, it decomposes, and when AgCl, that is silver chloride, it decomposes, it gives you silver plus chlorine gas, and silver that comes out, it comes out as a black powder. Okay, it's left out behind as a black powder. Now let's look at these equations in this box right here. Identification of HCl gas. When jar is completely filled with HCl, fumes appear above the jar's mouth. So white dense fumes, some fumes appear. So not white dense fumes, but you can see whitish fumes coming from the top of the jar, which identifies that HCl gas is present in the jar. The second important identification is about dense white fumes. So you have ammonium, you have ammonia. When it is brought near HCl, you get dense white fumes of ammonium chloride. So either you can take ammonia or you can take ammonium hydroxide. The bottom line is that you should be able to get ammonium chloride. So if you're getting ammonium chloride, you'll get dense white fumes. Very important identification. The next is fountain experiment. Fountain experiment, blue litmus solution turns red due to the acidic nature of the HCl gas. In these notes, I have just accommodated observations, what is happening, the changes that are happening. Then dilute HCl with thiosulfate. Now this comes out after sulfides. Okay, so you did sulfides. So after that you get thiosulfates. So with thiosulfates, this equation is very important. This is an exceptional case, you can say. So when dilute HCl reacts with thiosulfates, so along with water and SO2, you also get sulfur as a precipitate. This is an important observation that you have to remember. You get a yellow precipitate which identifies that the reactant is a thiosulfate. So that is the reason this equation is important. In the observation, they can give you an identification that when HCl reacts with this particular compound, you get a yellow precipitate. So what is your guess on it? So of course, what do you think the product is? Sulfur. Then you also have to identify it. So in that case, you can also say that okay, the reactant is thiosulfate. This is how the reaction is happening, and sulfur is coming out as a precipitate at the end. Now the next one, this is again very important, precipitation reaction. So HCl does not usually react with nitrates, but you do have three equations with nitrates. One is with lead, mercury and silver. All three are very important. When your HCl is reacting with lead nitrate, you get a white precipitate which is PbCl2. So let's look at it. You have lead nitrate reacting with HCl, which is giving you PbCl2, which is a white PPT, plus nitric acid. When you keep giving it heat, that means the reaction is happening and you keep heating it. In that case, the white PPT dissolves. Okay. So what is the basic understanding? Lead nitrate reacts with HCl, gives a white PPT and nitric acid. I keep giving it heat, the PPT dissolves. End of it. The second one, mercury nitrate. So when you have mercury nitrate, that also gives you a white PPT and you don't have any other information required for this particular equation. So mercury nitrate reacting with HCl, I again get a white PPT plus nitric acid. Let's move to the third one. That is the most important one. Silver nitrate. Okay guys, pay attention on this very closely. Silver nitrate reacts with HCl. It will also give you a curdy white PPT plus nitric acid. Okay, basic equation. Silver nitrate reacting with hydrochloric acid, giving me silver chloride plus nitric acid, and my silver chloride is a white PPT. Okay, Now this particular white PPT is insoluble in nitric acid, okay, but it is soluble in sodium hydroxide. Understood? Now we have the reaction with sodium hydroxide. So AgCl plus sodium hydroxide will give you diamine silver chloride, which is NH3 whole twice, and then you have a positive sign with that, and chlorine, of course, because you have the polar covalency there, so plus and minus. So you have this is silver diamine silver chloride plus water comes out. Okay. Now this complex compound which is coming along with water, when we react this with nitric acid, you get the white PPT of silver chloride again. Okay, let's do this again. You have silver nitrate reacting with hydrochloric acid, giving you AgCl plus HNO3. This AgCl is a curdy white PPT, which is insoluble in nitric acid, but soluble in ammonium hydroxide. When it reacts with ammonium hydroxide, it gives me a complex compound that is diamine silver chloride plus water. This diamine silver chloride and water, when I react this with nitric acid, I get back AgCl, that is the white PPT. Okay, makes sense? So this is very important. They can ask you this question in many ways. I'll give you an example at the end what kind of questions can come up. Now let's look at the next equation, that is MnO2 plus 4HCl gives you MnCl2 plus water plus chlorine gas. This is also an important equation. So make sure that you mark all the important equations. This side of the entire page is important. Okay. Now let's move ahead to ammonia. Let's get started with ammonia now. So ammonia, what is the difference in odor? That it has a pungent smell. What is the general or the first lab preparation? Both of them you can pick up the same. So in general prep, you have any ammonium salt that is reacting with, you can say alkali. So you have slaked lime. So you can react with that, and then you get a chloride, water, and ammonia gas. So for this case, I have picked up a common example, which is also valid for general preparation and also valid for lab preparation. That is the first lab preparation of ammonia gas. So let's look at this. So you have ammonium chloride reacting with CaOH whole twice. In present, like you are heating them up, you get calcium chloride plus water plus ammonia gas. Okay, extremely simple. Now all ammonium salts, when we heat it up, they give up ammonia except these two examples. So these two are exceptional cases. Except these two examples, that is NH4NO3 on heating will give me N2O plus H2O plus water. And the next one is NH4NO2, which gives us nitrogen gas plus water. The first one you have to remember is explosive. So that is also an identification for this particular compound. Then the next one is the second lab preparation. This is considered an expensive one. So we don't really prefer the second lab preparation of ammonia, but you need to know it. So the lab preparation with a metal nitrate. So metal nitride. So you have magnesium nitride and aluminium nitride. When they both react with warm water, they give you a hydroxide and ammonia gas. Okay. Now let's move to the next one, that is catalytic oxidation of ammonia. So you have ammonia and you are adding oxygen to it. So when you add oxygen to it in the presence of platinum at 800 degrees Celsius, you end up getting water plus NO plus heat. This NO combines with oxygen again and gives you NO2, which is nitrogen dioxide, which is a reddish brown gas. This is an identification of nitrogen dioxide. Okay. So what is the identification for this particular equation? Reddish brown gas of NO2. Then platinum continues to glow because the reaction is exothermic. So the catalyst that you are using, it continues to glow even when the reaction finishes up. That is because of the extra heat that this reaction produces when it is going on. Now let's move to the next one. Ammonia as a reducing agent. So ammonia reacting with black solid, that is copper oxide, giving you a reddish brown solid, that is copper, plus water plus nitrogen gas. So you have to remember it's copper oxide, that is the black solid, reacting with copper, that is reddish brown solid, giving you water plus N2. Now let's move on to the next one, that is lead oxide. When it reacts with ammonia, it gives you, so initially it was yellow in color. Now you get a grayish compound plus water plus nitrogen gas. Okay. Let's move to the next one. Reaction with acid. So ammonia being basic in nature, it reacts with acids. So let's look at that. So ammonia, that is NH3, reacts with HCl gas, that gives you NH4Cl. Then you have the thermal decomposition of NH4Cl and NH4NO3. So you have a basic thermal decomposition, that is ammonia comes and HCl comes and N2O comes and water comes. Okay. Now let's come on this side. Now this side I have Haber's process. Now I have not explained the entire Haber's process in this session. If you want to check that out, you can check out the ammonia one short video. In that everything is detailed, explained in detail. In this case I've only written the equation and what is the catalyst or what are the conditions required for this reaction. So let's start with that. You have nitrogen reacting with hydrogen in the presence of finely divided iron or molybdenum, and this reaction happens at 450 to 500 degrees Celsius at 280 atm. Now ammonia comes and heat comes. Let's come to the next one, fountain experiment. In fountain experiment, this is exactly opposite of HCl. So you get ammonia gas being basic in nature changes red litmus to blue. That is the observation of this fountain experiment. Moving on to the next one, burning of ammonia in oxygen. So you have ammonia reacting with oxygen, which gives you nitrogen gas and water. Now ammonia burns with a greenish yellow flame. Observation again. Ammonia burns with a greenish yellow flame and produces water vapor and nitrogen. This is also an exothermic process. So when this reaction happens, everything comes out in vapor, so you don't really see anything left out behind. Now next is reduction of chlorine to HCl. You have two cases in this one, when ammonia is taken in axis and when chlorine is taken in axis. So reduction of chlorine to HCl. How are we reducing it? You take you take ammonia and you react chlorine with it. So you get nitrogen plus NH4Cl. Okay. In this case, you get a yellowish green color of chlorine. Yellowish green color of chlorine disappears because you're reacting chlorine right here. So you initially when you were reacting the two gases, you had a yellowish green color because of chlorine's color. Okay. As the reaction proceeds, this yellowish color will disappear and dense white fumes appear of ammonium chloride. Okay. Now in the next case, you are taking chlorine in axis. So when you are taking chlorine in axis, ammonia reacting with chlorine will give you HCl plus NCl3. Okay. Now yellow color colored highly explosive liquid nitrogen trifluoride. Okay. So it's a yellow colored highly explosive liquid. So you need to know that is nitrogen trifluoride. Okay. Let's move to the next page. In the next page, if you see, you have the aqueous solution of ammonia. What is aqueous solution? You have ammonium hydroxide reacting. So what is aqueous solution? If you understand, you have ammonia combined with water. So aqueous solution of ammonia is nothing but ammonium hydroxide. Okay. When I say aqueous solution of ammonia here, your ammonium hydroxide is reacting with HCl, giving you NH4Cl plus H2O. Okay, that is salt plus water. Moving on to the next one, reactions with metal salts. Okay, now this is also a part of analytical chemistry. So if you have already done this, you don't have to stick around with this part and you can jump to the next part of the video and you can continue. So I'll still do this for the students who have no idea about this. So you have different type of metal salts which are reacting with ammonium hydroxide. First, you provide ammonium hydroxide in less quantity drop wise and then in axis. That means you continue adding it even when you have a precipitate already found. So let's look at it. Ferrous sulfate reacting with ammonium hydroxide gives you NH4 whole twice SO4 plus FeOH whole twice. This FeOH whole twice is the PPT that you get, and if you see right in front of it, I have a box. So this box entirely is together. So you can either just learn one of these boxes, that is these are your ions. Okay, these are the colors of the PPTs that they form, and in axis they are insoluble or soluble, that is mentioned. So these are your different things mentioned in this box. if you are not comfortable learning all the equations, you can also just learn this chart and this will help you with observation questions. But to not lose any marks, of course, you need to know all the equations. So let's start with this. So you have FeCl3 plus reacting with ammonium hydroxide. You get FeOH whole thrice, which is a reddish brown PPT, which is insoluble in excess of ammonium hydroxide. Similarly, you have for lead, zinc and copper. If you have any doubts about these, please make sure that you let me know in the comment section. Alright students, let's look at the following sheet. So this sheet I have made, which contains all the gases, and it has the color and the odor and also the identification. So you need to remember all the identification because all of these are part of observation questions. So let's start with carbon dioxide. So carbon dioxide is a colorless, odorless gas which turns lime water milky. Sulfur dioxide is a colorless gas with a burning sulfur smell, which decolorizes pink color of acidified potassium permanganate solution. Hydrogen sulfide is a colorless rotten egg smell, which turns lead acetate paper blue-black. Then next you have hydrogen chloride gas. You have colorless fumes in moist air and a pungent suffocating smell. Glass rod dipped in ammonium hydroxide, brought near it, you get dense white fumes of ammonium chloride. Okay. Nitrogen dioxide. This is a reddish brown gas which has a pungent suffocating odor. This turns potassium iodide paper brown. Next you have hydrogen. Hydrogen is a colorless, odorless gas which burns with a pop sound, which also burns with a blue flame when a burning splint is brought near it. So it won't extinguish it, it starts burning with a blue flame. Next is ammonia, which is a colorless, pungent, irritating gas, gives dense white fumes with HCl. Alright students, let's move ahead to the most interesting part of today's session, that is questions. Now, in the previous chart that I just discussed about gases, I forgot to mention chlorine. So you can mention chlorine here. It is greenish yellow in color and it turns moist starched iodide paper blue-black. So you can mention those things in your own chart. Now let's get started with the questions. Now pay attention on the questions. Any question that does not ask for an equation, you are not supposed to give an equation. So it's not mandatory to give an equation. You can simply give the observation for that particular test or particular question, and that would be all. If they are specifically mentioned, give a balanced equation, then yes, you will lose marks if you're not mentioning the equations. So let's get started with the first question. So the first question is, two colorless gases which when mixed produce I think it is wrote twice. When mixed produce a white solid. So two gases when mixed produce a white solid. I told you this was ammonia gas reacting with hydrogen chloride gas giving you NH4Cl, that is ammonium chloride, which is a white solid. So you have to just give two colorless gases, you have to give the names and then the final product, that is the white solid. If you give an equation, well and good, but it's not mandatory. Okay. Now let's move ahead to the second one. Two gases which chemically combine to form a liquid. Very interesting question, guys. This is a very common question and you would have done it a million times, but sometimes during the exams you just do not remember it. So two gases which chemically combine to form a liquid is hydrogen gas combining with oxygen gas giving you water. Let's move to the third question. A chloride which is soluble in excess of ammonium hydroxide. So if you just randomly think about this, it would happen that you will relate this to analytical chemistry and you will try to recall everything from there. So the chloride that is soluble in excess of ammonium hydroxide is silver chloride. If you remember that when we were doing hydrogen chloride, I told you about about silver nitrate. So it was giving you silver chloride. That silver chloride was insoluble in nitric acid, but it was soluble in ammonium hydroxide. So this is silver chloride that we are talking about. So silver chloride is soluble in excess of ammonium hydroxide. Let's move to the next one. The experiment which demonstrates that hydrogen chloride is soluble in water, that is fountain experiment. Now let's move to the second question. Solution A reacts with an acid B. Okay, so solution A reacts with an acid B. So B is an acid which produces greenish yellow gas on reacting with oxidizing agents like Pb3O4. So this bracket information is about this acid B. So you have to think about an acid which gives you a greenish yellow gas. Which one is the greenish yellow gas from the chart? If you remember, that is chlorine gas. So which acid will give you chlorine gas on being oxidized? That would be HCl. So your acid B is HCl. Okay. Solution A reacts with HCl to give a white PPT which is insoluble in nitric acid. So there is one white PPT which was insoluble in nitric acid, and that was silver. If you remember silver nitrate, we were reacting silver nitrate with HCl giving you AgCl. That was the white PPT insoluble in nitric acid but soluble in ammonium hydroxide, named A, B and C. Very simple, we just discussed that. So your solution A will be silver nitrate. Solution B is HCl and your solution C is the white PPT, that is AgCl. Okay, let's move ahead to the next one. A solution of hydrogen chloride in water is prepared. The following substances are added to separate portions of the solution. Okay, so you have to tell the gas evolved and the odor. So when you have something like this, that you have the compounds given and you are adding hydrogen chloride to it. So you are adding HCl to it. So always remember the basic properties that I told you about hydrogen chloride. Always remember the equations in a particular manner. Okay. So since you do not have any nitrates here, so there is no exceptional cases, everything is valid here. And the only thing you have to check is that the metal or any compound that you are reacting, it is above hydrogen in the reactivity series. So let's look at these. So calcium carbonate. So you have carbonate. So that means it will give you carbon dioxide. What is the odor? It does not have a smell. So it is odorless. Then next is magnesium ribbon. So only magnesium, only metal is reacting with HCl. You will get hydrogen gas. What is the odor of hydrogen gas? It is odorless. Then manganese oxide. So you have oxide. So what will you get? Manganese oxide. Okay, so you have manganese oxide. So manganese oxide is the one that you have in the oxidizing agent. So manganese oxide will give you chlorine gas. Okay, and what is the odor of chlorine gas? It is a pungent odor. Then sodium sulfide, IDE, sulfide will give you H2S gas. And what is the smell of H2S gas? That is rotten egg. Now let's move ahead to question 4. How will the action of dilute HCl enable you to distinguish between the following? So again, a lot of students get confused that are we supposed to give the equation or not? Since they are not asking it, it is completely up to you whether you mention the equation or not. As long as you are able to give them the observation, you are good to go. Okay. So let's look at this question. So they are asking you to differentiate between sodium carbonate and sodium sulfide. Now, if in a usual case, if you do remember equations, go ahead, write the two equations and you can differentiate it. If you do not remember the equations, but you have an idea that carbonate will give me carbon dioxide gas and sulfide, what will sulfide give you? It will give you SO2 gas. So if you have that idea, just one second, the previous one was sodium sulfide, IDE. Yeah. So if you have that much idea, so in that case, what would happen is that only just by the observation, you can easily give the answer. Okay. So let's look at this. So the first one that they're talking about is sodium. Okay. So for sodium sulfide and carbonate. So for carbonate, if you see, you can directly give them carbon dioxide. And for sulfide, you have H2S gas, right? So you have H2S, IDE, you have H2S gas. So you can simply give that. So how will you write the answer for this one? So for sodium carbonate, you'll say a colorless, odorless gas is evolved, which turns lime water milky. So that will be your observation. For the second case, you'll say when sodium sulfide reacts with dilute HCl, we end up getting you can say a colorless rotten egg smelling gas, that is H2S gas. Okay, so that is how you will differentiate between these. Now for the next one, sodium thiosulfate and sodium sulfite. So for sodium thiosulfate, you will say that you get SO2 plus sulfur, that is a yellow PPT. And for the second one, you will say you do not, so SO2 is there, so SO2 is evolved, but you do not get a PPT. Do not get a PPT. Okay, so this is the information that you can mention. If for any particular question you're not clear with what the answer is, make sure that you can ask me in the comment section or on the Telegram channel, and I will definitely let you know if you have any confusions. Now let's move ahead to question 5. Lead nitrate solution is mixed with dilute hydrochloric acid. So lead nitrate, do you remember we did 3 nitrates, lead, mercury and silver. So lead nitrate, the observation for lead nitrate was that you get a white PPT, that was lead chloride, and it dissolves when you keep heating it. So a white PPT is got, and that dissolves when we continue to heat it. If you remember the equation, well and good, mention that in the answer. Next one, a small piece of zinc is added to dilute hydrochloric acid. So zinc is added alone, okay, so there is nothing else. So when a metal is directly treated or reacted with HCl, you get hydrogen gas. So that is the observation that you can mention. A colorless, odorless gas is evolved which burns with a pop sound. That is a sufficient amount of answer. Okay, let's move to the next one. Identify the gas evolved when. So potassium sulfite is treated with dilute hydrochloric acid. So that would be your SO2 gas. Then next is, now when they say identify the gas evolved, so you have to name the gas that SO2 is being evolved and what is the confirmation test for it. So you can mention colorless, odorless, XYZ, whatever you know, and then a confirmation test for it. That you can pick up from the chart directly. Now next is concentrated HCl is made to react with manganese dioxide. So manganese dioxide, again, that is the oxidizing equation that you have. So you can directly mention that. So which gas comes out? You'll get chlorine gas. So you'll mention greenish yellow gas is evolved, which turns moist starch iodide paper blue-black. So that you can mention. Now, question number 7. State one appropriate observation when copper sulfide is treated with hydrochloric acid. Again, you have sulfide, so you accordingly write that you get H2S gas. Then next is a few drops of dilute HCl are added to AgNO3 solution. So again, silver nitrate. I have told you a million times, silver nitrate, very important equations. All the concept is important. So silver nitrate solution followed by the addition of ammonium hydroxide. So think about it in steps. So when silver nitrate, you have silver nitrate and you are adding dilute HCl to it, you get silver chloride, which is a curdy white PPT. Then you'll say when AgCl reacts with ammonium hydroxide solution. So your observation will be a curdy white PPT of AgCl appears which dissolves in ammonium hydroxide solution. Okay, so this will be your observation. So first you'll mention clearly that a PPT has appeared, and then it dissolves in ammonium hydroxide. So you have to mention both the things. Let's move to question number 8. A gas P gives dense white fumes with chlorine. Its aqueous solution gives blue color with copper hydroxide. Give the name and formula of the gas. So a gas P gives dense white fumes with chlorine. So that would be with chlorine. That means what is the gas coming out? You have ammonium chloride that gives you dense white fumes. So a gas which gives dense white fumes with chlorine, that will be ammonia. Its aqueous solution gives blue color with copper hydroxide. Give the name and formula of the gas P. So the answer is ammonia. Okay. If you have any doubts, please make sure that you can ask me anything. Next is ammonia solution in water gives blue PPT when it combines with a solution of copper salt. The blue litmus precipitate further dissolves in excess of ammonium solution to give an azure blue solution. Explain with equation. Now, there, do you see very clearly? In this case, you're supposed to give the equation. Now, the chart that we did towards the end of ammonia, I can go back and show you that. So it was this one. This is really, really important, students. Okay. So remembering all these equations, the color of the PPT and their action when you have access of compound provided, whether it's soluble, insoluble, this entire information is very important. So this particular question is based upon this last equation. So you have copper sulfate. So you get a copper pale blue PPT and it is soluble in excess of sodium hydroxide. So it gives you a blue solution when it dissolves. So you get a blue PPT, it dissolves in the solution and gives you a blue solution. Okay, so this is what they are talking about. Okay, now similarly you have a lot of questions which will come up from this section. So make sure that you remember this very clearly. I won't be going up and down again and again to give you the reference because that will waste a little bit of our time. So make sure that you read the question and come back on the chart for reference. Now let's move ahead. We did this one, we did 8th and we did 9th. Now, what do you observe when ammonium hydroxide is added to the aqueous solution of ferrous sulfate? So in this, you just have to mention the color of the PPTs that you're getting. Then iron 3 chloride, lead nitrate, zinc nitrate. So white gelatinous PPT, reddish brown PPT, dirty green PPT, all of that you have to mention here. Okay, so those will be your observation, but you have to make sure that you write them very properly, that when this and this is reacting, we'll find or we'll get this colored PPT. Underline the color of the PPT, please. Okay, so that will be your observation. Now, distinguish between the following using ammonia solution. So, calcium chloride and zinc chloride. Okay. So, calcium chloride does not react with ammonia solution. So, your first portion for this would be that there is no reaction with calcium chloride. Whereas, on the other hand, with zinc chloride, and then you can give the reaction. That zinc chloride, you have ammonia. So, what is happening? Then ferric salt and ferrous salt, again, you can directly distinguish based only on the observation. You can say dirty green precipitate or reddish brown precipitate, but write them properly, students. Write the whole sentences, not just the name of the PPT or the color of the PPT, but underline the color of the PPT. Okay, if you have any confusion on how to write the answers, there is a video that is uploaded which is tips and tricks on how to write the answers. Make sure that you check that out. I have shown few toppers answer scripts and explained how I'm expecting you to write the answers for the board exams so that you don't lose any marks anywhere. Let's move to the next one, zinc nitrate and lead nitrate. Again, you can give gelatinous white PPT and white PPT. Next is identify the substance Q based on the information given. The white crystalline solid Q is soluble in water. It liberates a pungent smelling gas when heated with sodium hydroxide solution. Okay, so whatever this Q is, when we are reacting it with sodium hydroxide, we are getting a pungent smelling gas. So that should be, so sodium hydroxide, so NaOH, and you have a pungent smelling gas coming out. So that would be what? That would be your ammonia gas. So what is the substance Q? What are you reacting sodium hydroxide with? So you can remember for the lab preparation for ammonia. So for with sodium hydroxide, you can easily react ammonium chloride. And when you're reacting ammonium chloride, you'll easily get the answer as ammonia in the products. Okay. Let's move ahead to the next one. Question number 13. State your observation when, in the absence of catalyst, ammonia is burned in the atmosphere of oxygen. So when ammonia burns in the absence of a catalyst and in oxygen, you get a greenish yellow flame. Then the next one is state your observation when water is added to the products formed when aluminium is burnt in a jar of nitrogen gas. Okay, this is a very interesting one. A lot of students get confused in it. So first thing is that you are not reacting water with aluminium directly. Aluminium reacted with nitrogen. The product that you got is reacting with water. So think about it. Aluminium and nitrogen together is giving you aluminium nitride, and that is reacting with water. So this is the second lab preparation of ammonia. Aluminium nitride reacting with water will give you ammonia and another compound, whatever you get. So that is the equation. So make and understand the question properly, read the question properly, and then put in the products and reactants. 15th, state two relevant observations for ammonium hydroxide solution is added to zinc nitrate solution slowly and then in access. So you'll simply say that when we are adding slowly, you get gelatinous white PPT, and then when you add in access, that particular PPT dissolves in the solution. So this is how you're supposed to frame the whole answer. Question 16. Distinguish between the following pairs of compounds using the tests given in the brackets. So in these, both of them are ammonium hydroxide, but in the exam, they can give you anything else. Now, iron 2 sulfate and iron 2 sulfate and iron 3 sulfate. So easily you can differentiate based upon the color of their PPTs, but distinguish, you just have to give the differentiation. So either you can give the whole difference, that is, first give the PPTs and then the solubility or insolubility based upon if that is a distinguishing factor or not. The next is lead salt and zinc salt. So again, similarly, you can clearly mention the color of the PPTs. If solubility or insolubility is a factor of distinguish between them, then mention it. Otherwise, you can skip it. That is also fine. You can just stick to the color of the PPTs formed when the reaction has happened. Now, these would be all for the questions. If you have any doubts in any particular questions, make sure that you can reach out to me in the comment section. So, my dear students, this is it for today's session. I am definitely sure that this session is helpful for you. I have given a lot of thought on all the questions and the portion that is covered. So, in about 40-45 minutes, you're easily able to cover all the observation questions, all the equations for ammonia as well as HCl. So, I hope this was really helpful for you. So, thank you so much. Make sure that you go ahead and subscribe to this channel. Also, you can connect with me on Telegram channel, and make sure that you share this video with your friends and help us move forward. Thank you so much. I hope you have a wonderful day ahead.